Good day, students. Today we are considering a topic titled Magnetic Force on a Charge Moving in a Magnetic Field. Magnetic field exerts a force on a charge moving in the field, and charges constitute an electric charges in motion constitute an electric current. For example, the motion of electron along a conducting wire. The strength of the magnetic field can be represented by a vector quantity B, which is called magnetic induction or flux density. Now let's see what we have on the board. A magnetic field exerts a force on a charge moving in the field. Charges in motion constitute an electric current. For example, the motion of the electrons along the conducting wires. The strength of magnetic field can be represented by a vector quantity B called flux density or magnetic induction. We use B to represent flux density or magnetic induction. If theta is the angle between the magnetic field direction and the direction of the motion of the charges, then the force F on the charge is given by, this formula is very important, F equals QVB sine theta. Q equals charges in coulomb, represented by C, letter C. V equals velocity of the motion of the electron in meter per second. B is the flux density of magnetic induction in Tesla. B, the unit of flux density of magnetic induction is Tesla, capital T. 1 Tesla is equivalent to 1 Weber per meter squared. Where V and B are in the same direction, that is the velocity of the motion of the electron and the flux density or magnetic induction, when they are in the same direction, the angle theta equals 0. The force equals 0 because sine theta equals sine 0 and is equal to 0. When V and B are at right angle, then sine theta equals sine 90 equals to 1. In that case, F equals to QVB. Okay, hence the charge moving in the direction parallel to a magnetic field experiences no force. A charge at rest in a magnetic field also experiences no force because V is 0. The vector F equals V cross B, where V cross B equals VB sine theta, is perpendicular to the plane containing V and B. Let's see the plane. You can see the magnetic flux density or magnetic induction, the flux density or the magnetic induction. You can see them, which is represented here. Magnetic induction, they are not parallel to each other, they are at an angle. Is that okay? And what you are now saying that you can see the force is perpendicular to them. The magnitude of the force is given as FQ equals to QVB sine theta. Now let's solve a problem. It can be at an angle to each other. You can see find the angle in this question. That's at an angle 90 degree. B and V at an angle 90 degree to each other. When it's 60 at an angle 60 degree, but when they are parallel to each other, it will be 0. Is that okay? That's why I said here that when they are parallel, when V and B are in the same direction, the angle theta equals 0. Let me say they are in the same direction. Let me say this is line on top of this, the velocity of the electron, or the motion of the electron, and also the magnetic induction or the flux density. When they are parallel to each other, 0 at that point. Now let's solve problem under this. When theta, the first one, when angle theta equals 90 degree, F equals QVB sine theta. Okay, what's our Q? The charge. Okay, let's write the parameters. The charge, what do we have as the charge here? We have the flux density B. equals to 10 Tesla, and the velocity equals 5 times 10 raised power 7. Okay, we're going to be using this to calculate and the meter per seconds, and you have the charge Q 1.6 times 10 power minus 19 coulomb. Okay, let's now solve the first one. When let's use this one, the general parameters. Now when theta equals 90 degree, your F now equals QVB sine theta, which is our Q 1.6 times 10 raised power minus 19 times V 5 times 10 raised power 7 times what's B 10 times sine 90 degree. Okay, F now, when you press your calculator, you have 1.6 times 5 times 10, you have 80, you have 80. Okay, let's multiply so that you see it. 1.5, 1.6, 5 times 10, that's 50. 50 times 1.6, that is 50 times 16 over 10, 0 cancel 0, that's 80. 80, you have 80 times 10 raised power minus 19 plus 7 times sine 90 is 1, which is 80 times 10 raised power minus 12. When you shift once, it becomes 8 times 10 raised power minus 12 plus 1, which is, you understand? Let me analyze it very well. This one now equals 8 times 10 raised power 1 times 10 raised power minus 12. F now equals 8 times 10 raised power 1 indices plus minus 12 equals 8 times 10 raised power minus 11 Newton. Okay, now when theta equals 60 degrees, still follow the same format. F equals 1.6 times 10 raised power minus 19 times 5 times 5 times 10 raised power 7 times 10 times sine 60 times sine 60 degree. Now F equals 1.6 times 10 raised power minus 19 times 5 times 10 raised power 7 is times 50. 5 times 10, that's 50 times 10 raised power 7 times 0.8660. When you press the calculator, you have 69.28 times 10 raised power minus 12. When you shift once, become 6.9 times 10 raised power 6.928. Let's put it here, equal to 6.928 times 10 raised power shifted once times 10 raised power 1 times 10 raised power minus 12 equals 6.928 times 10 raised power 1 plus minus 12, okay, which is equals to 6.928 times 10 to the power minus 11 Newton. The third one, when theta equals to 0. Now F equals QVB sine theta. Because your theta is 0, everything will be 0. QVB sine is 0 equals to 0. Okay. When V and B are parallel. Okay. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.